But this is going to be really tough to see, so how are we going to actually determine what the right answer is?
If I were to drop it now, it would happen so fast you wouldn't really see clearly what's happening. So I've brought along my slow motion camera, and you'll see it at 300 frames per second, and it's quite spectacular.
Well, that's ultra slow-mo, so that's exactly what we need to sort out this problem.
We'll give a countdown, because it happens really fast.
All right.
3, 2, 1, drop.
Wow, did you see that?
I didn't really see which happened first. No, I need to slow that down.
Well, let's go to a slow motion replay and see what actually happened. So from the slow motion camera, we can clearly see that the bottom end stayed completely stationary even after you let go of the top. It waited until the whole Slinky had collapsed down to the bottom before it itself moved downwards. How do we explain that?
Well, there are a number of explanations, but the simplest explanation is that the bottom end is sitting there minding its own business with gravity pulling it down and tension pulling it up, equal and opposite forces, no motion at the bottom end until the bottom end gets the information that the tension has changed. And it takes time for that information to propagate down through the Slinky to reach the bottom end. So it's propagating down as a compressional wave.
And we saw that compression wave travel down, and it has to reach the bottom before the bottom even knows that you've let go at the top.
Correct.
And that's when it knows to start falling.
Correct.
That's a really remarkable finding. I mean, does this apply to any other objects, or is it just Slinkies?
No, it applies to the real world. Particularly in sports, which is the field I'm interested in. For example, when a player hits a ball, there's a huge force at the business end, but that force is not felt at the handle end until the ball is well on its way. So a wave has to propagate from the business end down to the handle end, and then it propagates back again, and what you actually feel down this end is considerably less than what the ball felt.
So, wow, if you're playing tennis or something, you only feel that you've hit the ball after you've actually hit the ball.
Yeah, the ball's nearly to the net by the time you actually feel what's happened.
That goes against, all your intuitions, that you really can feel it as soon as the ball's on your racket.
It's the same in golf. If you whack a golf ball, you often find golfers will finish with a nice flourish, thinking that it has some effect on the ball, but of course the ball is halfway to the hole by the time that happens.
Of course. Now, what if we wanted to do a little extension activity? I want you to make a prediction. If we attach this tennis ball onto the base of the Slinky and we drop it again, what will happen to the tennis ball? Will it do the same as the base of the Slinky and just stay there? Or will it fall with the acceleration due to gravity g? Or will it go upwards?
Well, we'll have to try it and find out.
All right, I'd like you to make your prediction now. Quick.